Have you ever wondered how submarines, those stealthy underwater vessels, came to be? The story of submarine technology dates back centuries, with early designs bearing little resemblance to the sleek, high-tech vessels we see today. The concept of submersible vessels actually began in the realm of whimsical wooden designs, born of the human desire to explore the mysteries of the deep. As time marched on, so too did technology. The 19th century saw the advent of the first mechanically propelled submarine, while the 20th century brought the USS Holland, the first fully functional modern submarine, to the fore in 1900. This vessel was a far cry from early wooden designs, boasting a dynamic blend of diesel-electric power and marking a significant leap in naval engineering. The USS Holland's successful launch did more than just make headlines. It marked the beginning of a technological revolution, setting the stage for the modern submarine. Submarines are marvels of engineering, built to withstand the immense pressures of the deep sea. Let's dive into the fascinating process of submarine construction, where every detail matters. At the heart of a submarine structure is the hull design. Crafted from high-strength steel or advanced composites, the hull is cylindrical, a shape that ensures both structural integrity and optimal underwater performance. This isn't just a shell, it's a meticulously engineered fortress designed to protect against the crushing pressures that exist thousands of feet below the ocean's surface. Inside this robust exterior, we find the pressure hull. This reinforced section is the submarine's true sanctuary, a stronghold within a stronghold. The pressure hull withstands not only the external pressure of the deep sea, but also safeguards the crew and the complex machinery that keeps the submarine operational. It's a marvel of engineering, combining strength, resilience, and precision design. Let's not forget about the ballast tanks, the unsung heroes of a submarine's operation. These tanks control buoyancy and depth, a critical function that allows the submarine to submerge or resurface. By adjusting the water levels in these tanks, the crew can guide the submarine up towards the sunlight or down into the mysterious depths. It's a delicate dance, a constant balancing act between water and air, weight and buoyancy. Each of these components plays a crucial role in a submarine's operation. Yet, their importance goes beyond their individual functions. They're part of a larger system, a symphony of engineering that intertwines strength, precision, and adaptability. Every piece, every part, every system is meticulously designed and constructed to work together, enabling these underwater behemoths to navigate the world beneath the waves. From the cylindrical hull to the internal pressure hull and the intricate ballast tanks, every element of a submarine's construction contributes to its ability to operate in one of the planet's most extreme environments. These components come together to create a vessel capable of exploring the ocean's darkest depths. And that, my friends, is the making of a submarine. A submarine's heart lies in its propulsion system, powering its stealthy underwater journey. The evolution of submarine propulsion systems is a study in technological strides. From the early days, submarines relied on diesel-electric engines. Diesel engines, while on the surface, charged batteries that powered electric motors for underwater propulsion. It was a system with limited endurance, necessitating frequent surfacing. Enter nuclear power, a real game changer. Nuclear power brought about a paradigm shift, transforming submarines into true underwater beasts. These nuclear-powered leviathans carry miniature nuclear reactors that heat up water, producing steam. This steam drives turbines connected to electric generators or directly propels the submarine, giving them virtually unlimited underwater endurance. This is a critical attribute for strategic deterrence, surveillance, and covert operations. But what about non-nuclear submarines? They've got a secret weapon too, air-independent propulsion or AIP. AIP systems build on the traditional diesel-electric setup, enhancing stealth and endurance by allowing extended submerged operation without surfacing. Whether it's fuel cells, Stirling engines, or closed-cycle diesel engines, AIP technology has given non-nuclear submarines a significant performance boost. In essence, it's these advanced propulsion systems that give submarines the endurance and stealth they need to carry out their covert operations. It's about staying under the radar, or rather under the sonar, for as long as possible. The longer a submarine can stay submerged, the more effective it can be. And that's the power behind these underwater beasts. Advanced propulsion systems give submarines the endurance and stealth they need to carry out their covert operations. navigating and communicating underwater presents unique challenges, met by sophisticated technologies. Imagine finding your way in a world without landmarks, where traditional compasses are unreliable and GPS signals can't penetrate. That's the reality for submarines. To overcome this, they rely on an intricate navigation system called inertial navigation. This system uses accelerometers and gyroscopes to calculate the vessel's position, velocity, and orientation without needing external references. But how do submarines communicate in this silent world? They use sonar, a system that sends out sound waves, which bounce off objects and return to the submarine, painting a picture of the surrounding environment. For longer-range communication, submarines surface to use radio and satellite technologies, enabling them to stay in touch with command centers and other vessels. These systems ensure a submarine's effective operation in the vast underwater environment. So next time you marvel at a submarine's ability to navigate the deep blue, remember the incredible technology that makes it possible. Stealth is a submarine's greatest ally, complemented by a suite of defensive systems. The clever use of technology to mask a submarine's presence underwater is truly a marvel. It starts with the design, where low observable shapes minimize detection. The hull itself is often coated with sound-absorbing materials that dampen engine noise and deflect sonar waves, making the submarine virtually invisible to enemy sensors. But stealth isn't just about hiding, it's also about protection. Defensive systems play a critical role in a submarine's survival strategy. Anti-submarine torpedoes are a common line of defense. These self-propelled weapons are designed to seek and destroy enemy submarines and ships. Additionally, decoys and countermeasures are employed to confuse and divert incoming attacks, providing an extra layer of security. So it's not just about being unseen, it's about being undetectable, untraceable, and untouchable. With stealth and defense, a submarine becomes a formidable presence in the ocean depths. The future of submarine technology is being shaped by advancements in automation and artificial intelligence. Modern submarines are integrating these technologies to elevate operational efficiency. Automated systems now control navigation, propulsion, and sensor data analysis, while artificial intelligence optimizes route planning, target identification, and threat assessment. These advancements are transforming submarines into intelligent entities capable of making calculated decisions. As technology evolves, so too does this submarine, promising even more formidable vessels in the future.